Here I'm going to look at mathematical induction again, going through a past paper question. In these set of questions I'm going to deal with the induction questions involving series. So when you have a sum of numbers equal to a set formula. That could be an arithmetic series or a geometric series. So we're going to have a look at this question. It came up in 2014. And it says to prove by induction that the sum of the first n natural numbers here is equal to this formula. We're going to follow the same strategy as did before. We're going to test the case for the first or the lowest number n, considering it's a natural number. That's going to be n equal to 1. Then we're going to assume it's true for n equal to k, and we're going to use that assumption to prove that it's true for n equal to k plus 1, p1. So we're testing n equal to 1. Well, we're basically showing that the sum of the first 1 numbers, which is 1, is equal to 1 times 1 plus 1 divided by 2, which is equal to 2 over 2, which is 1. So it is true for n equal to 1. The next step is to assume that Pn is true for n equal to k. So we assume it's true for the proposition n equal to k. So that is 1 plus 2 plus 3 all the way up to plus k is equal to k outside of k plus 1 over 2. So we're going to use the assumption here that 1 plus 2 all the way up to plus k is equal to k times k plus 1 all over 2 in our proof for n equal to k plus 1. So we are trying to prove that k plus 1 is equal to k plus 1 times k plus 1 plus 1, which is k plus 2 all over 2. So we're trying to prove that the left hand side here is equal to the right hand side. So well, the left hand side is equal to 1 plus 2 plus 3 plus k plus 1. Well, I know that this here is equal to the other highlighted green part because that's in the assumption. So that's equal to k inside of k plus 1 all over 2 plus k plus 1. And the aim of this is that I will hopefully show that this right hand side is equal to this. What I need to do is tidy up this and hope that it's equal to the one above it. If I've done that, then I've proven that it's true for n equal to k plus 1. So just tidying up the lower highlighted section here in yellow, we have k outside of k plus 1 all over 2 plus k plus 1. Well, what I need to do is just add the two fractions together. So I'm going to multiply that by 2 and then simultaneously divide by 2. So just combining my two fractions here, I've got k outside of k plus 1 plus 2 outside of k plus 1 all over 2. Well, if I just factorize there, that's equal to k plus 1 outside of k plus 2, because I take those two together, all over 2, which is what I wanted it to be at the beginning. So I've proven that it is true for k plus 1 based on the assumption that it was true for n equal to k. I've also shown that it's true for n equal to 1, so therefore I've proved by induction that the sum of the first natural numbers is equal to n outside of n plus 1 all over 2. So I've just written here that the left hand side was equal to the right hand side, i.e. this part was equal to this part. Therefore pk plus 1, the proposition k plus 1, was true if pk is true, hence by induction pn is true. The next question I'm going to look at is another series question. It came up in 2012. It's proof by induction the formula for the sum of the first n terms of a geometric series. So instead of it being an arithmetic, we're now on to the geometric series. So we're testing for the first term, that's n equal to 1. Our first term is a, and we're going to show that that left hand side a is equal to the right hand side when n equal to 1. So that's a outside of 1 minus or to the 1 divided by 1 minus or. Well, 1 minus or over 1 minus or is just 1. So we're left with a equal to a, which is true. So it is true for n equal to 1. The next thing we do then is assume it's true for n equal to k. So if we assume it's true for n equal to k, pk therefore is a plus a to the or squared, a to the or k minus 1 is equal to a outside of 1 minus or to the k 1 minus or. And our next step now is the same as usual, test for or prove for n equal to k plus 1. So we're testing p, the proposition of n equal to k plus 1. So that means that a plus a to the or plus a to the or squared plus a to the or k minus 1 plus a to the or k is equal to what we expect it to equal to, which is a outside of 1 minus or to the k plus 1 over 1 minus or. So this is our left hand side, and we want to show that that left hand side is equal to the right hand side. And what we do is we'll work through the left hand side again and show that it should be equal to the right hand side. So if we remember, this is the sum of the first k terms, which we've assumed to be true, which is equal to this part here. So I'm going to use that in testing for pk plus 1. So our left hand side just equals this green part here, which is equal to that. So that is just a outside of 1 minus or to the k all over 1 minus or. Now plus, I have to take this and bring it down here, plus a times or to the k. And we want to show that it is equal to the right hand side. As the right hand side here is neatly expressed in one term, I want to bring the left hand side together into one term and show that it is equal to this right hand side. Okay, so first step is trying to convert that into a fraction with the same denominator so we can add them. So our left hand side becomes a outside of 1 minus or to the k, 1 minus or, plus a outside of or to the k times 1 minus or all over 1 minus or. So I've just created two fractions with the same denominator so I can add them together. And what I'm going to do is I'm going to expand out both sets of brackets and combine. So it's going to be a times 1, which is a times minus or to the k, which is minus a or to the k. Then when we move on to the right hand side, it's a or to the k plus a or to the power of k times 1, which is plus a times or to the k, minus a times or to the k. Well, that's just equal to a, these two terms cancel out, minus a outside of or to the k plus 1 all over 1 minus or. Again, if I just take the a outside now, it's a outside of 1 minus or to the k plus 1 all over 1 minus or. And hopefully I've shown that that here is the same as the right hand side that I was expecting to get above, which it is. Okay, so similar to the last question, I've shown that the left hand side here is equal to the right hand side here. So I've proven it true for n equal to k plus 1 based on the assumption that it was true for n equal to k. I've also shown that it's true for the first member of the series, n equal to 1. So therefore I've proved by mathematical induction that the sum of the first n terms of a geometric series is a outside of 1 minus or to the power of n, all divided by 1 minus or. Okay, so there are two proof by inductions using series.